Hey, welcome back. In this lesson, we're going to look at math operations. So add, subtract, multiply, divide, and modulo. And we're going to look at how those different math operations behave with different data types in Java. So let's start with an output, so system.out.println, and let's go ahead and do addition with doubles. So if we take 1.5 and we add 2.5 to it, right, let's see what happens. So we'll go ahead and run. Okay, and our answer is what we would expect, 4, but when we add a double plus a double, the answer is a data type double. And remember, doubles are decimal numbers. So even though 1.5 plus 2.5 adds to 4, which is an integer, because it's stored as a double, it's going to respond with a 4.0, right? A double plus a double equals a double. Okay, the same thing is going to be true with subtraction. So when I subtract a double from a double, I'm going to get a double back as my answer. So we'll go ahead and run that, and we can see we get 1.5 minus 2.5 equals negative 1.0. Okay, if we multiply, to a times, and multiply in Java is the asterisk symbol, and then we can run. So 1.5 times 2.5 is 3.75, and then we can also divide, and let's make this a little bit easier to divide. So we'll start with 4 divided by 2. And the division symbol in Java is the slash. So let's go ahead and run that. Okay, so now let's look at what mistake I made. Right? 4 is an integer, not a double. 2 is an integer, not a double. And notice when we divide an integer by an integer, we get an integer back. Right? So this statement really should be under our operations with integers. So let's now change that by making the value 4.0 divided by the value 2.0. By adding that 0.0 in, now these are considered decimal numbers in Java instead of integer numbers in Java. So let's go ahead and run. Okay, and we can see 4.0 divided by 2.0 returns 2.0. Okay, now let's look what happens when we mix those together. So we're going to have an operation with an integer and a double. So if I take this integer 4 and I divide it by a double, 2.0, let's see what gets returned. Okay, so we get a 2.0. So an integer divided by a double is going to return a double. And that would be the same if we made either one of those values in the division the integer versus the double. If any of those values is a double, then the answer of the division is going to be a double. Okay. Another thing to look at that's interesting with integer division. Okay, let's try first the double division. And let's divide something that doesn't go in evenly. So let's do, say, 10 divided by 3. Okay? And we're going to look at that as doubles being divided. Then we're going to look at what happens when it's integers being divided. And then we'll take a look at what happens when it's both. So an integer divided by a double. Now I'm going to go ahead and comment out all these other lines. So they'll get ignored by Java, and we can just compare these three outputs. So 10.0 divided by 3.0, 10 divided by 3, and then 10 divided by 3.0. Okay, so we can see in our output, when we divide a double by a double, we get a double answer. Same for the mix. When we take an int divided by a double, we get the same double answer. Okay, but when we divide an integer by an integer, notice it's truncated. The result of an integer divided by an integer is an integer, and it just discards the decimal that came after. Okay, so integer division is going to behave differently from double division. It's going to throw out any decimal that is after the integer solution. Okay, another thing that's interesting in division is to look at what happens when we divide by 0. So in math classes, right, we have learned thou shalt not divide by 0, because that answer would be undefined. So let's look at these one at a time. So I'm going to comment out these two, and we're going to try first just the 10.0 divided by 0.0 and see what happens. Okay, and there's our answer, infinity. Okay, so that's like in math where we say the answer is undefined, right? We're going to infinity. Now, when we divide an integer by 0, let's take a look at what happens. Okay, now this time we have an error. We have an error at compile time, so this program didn't even run. And it tells us there is an exception in thread main, and it's an arithmetic exception, divide by 0. So we can't divide by 0 when we're dividing integers, but we can divide by 0 in Java when we're dividing doubles, right? That will compile and run, and it'll output infinity as the solution, since that's an undefined answer. But for integers, Java says, no, you can't divide by 0, so this won't even compile. Okay, now let's take a look at what happens when we have one of each. And we get that infinity again. So when we mix integers and doubles together in the division, and it doesn't matter whether the first number is the double or the second number is the double, right? When we have a mix, it's going to treat this as a double. So a double divided by a double is going to give us a response of infinity, and this program would compile and run. Okay, another fun operation to try with your integers is one that we don't use very in high school math classes, and that's modulus. So 10 modulus 3. Okay, and we'll go ahead and let this line above print as well. So if we divide 10 by 3, as an integer, we know that it's going to discard any decimal value that comes after and only give us that whole number that divides evenly into 10. The modulo operator, this percent sign, this is going to capture that remainder that got discarded. Okay? So the modulus operator is going to take the 10, divide it by 3, it's going to tell us what's the remainder after we do that division. So let's go ahead and run. Okay, so 10 divided by 3 as an integer is 3 because 3 will go into 10 evenly 3 times. But the modulus gives us the remainder. The remainder of that division is 1, right? So 3 times 3 is 9, plus 1 gives us that 10. And so that modulus operation we use very often when we're writing programs. And one of the most common ways that we use it is to check for even or odd numbers. So 10 mod 2, the integer, the remainder there, the integer is 0, and that means that 10 is an even number. Okay, if I change that to a 13, and now when I run, since 13 is an odd number, right, I get a 1 back, there's a remainder, so 2 didn't go in evenly. That tells me that 13 was odd. Okay, another common application of modulus when we're programming is to capture the last digit of a division or of a number, and we can do that with mod 10. Okay, so 13 mod 10 is going to divide 13 by 10. We'll have a remainder of 3, and you can see how that captures that last digit. If I had the number 135, right, 135 mod 10, that would capture the 5 then as the last digit. If I wanted to capture more than one digit, so say I had 1,350, and I wanted to get the last 2 digits of that number, I would do mod 100, right? And that would shift 2 digits over as my remainder, and my remainder then would be 50. So let's go ahead and try one that's even a little bigger. So let's do 13,520 will capture 3 digits this time, and we should get 520 as our answer. Okay, and there it is. Okay. So next, let's talk a little bit about operations with concatenation. Okay, so we learned that concatenation is when we use the plus sign with strings. So if we have a system.out.println and we add 5 plus 2 plus, and then let's make a string that says hello. Okay, so the 5 is an integer, the 2 is an integer, hello is a string. Java's precedence is going to treat addition and concatenation in order from left to right. So the 5 and the 2, because they come first, they're both integers, they'll get added, and that'll be a 7. Then that gets concatenated or joined together with the string hello. So this should output 7 hello. So let's go ahead and try that. Okay, and there we go. Now, if I move that string, so I'm going to make the string first. So we're going to do hello plus 5 plus 2. So hello plus 5 plus 2. Now, we're tempted to think that Java would add the numbers again to get 7, and this would just be hello 7. But the precedence is from left to right, and it's the same level of precedence for strings versus concatenation of strings versus padding of integers. So the first thing we come to is a string. So that gets concatenated with the 5. So now we have hello 5. That's a string. So the next plus sign is concatenation, and this will output hello 5, 2. So let's go ahead and compile and run. Oh, whoops, I lost my semicolon. There we go. Let's try that again. Okay, and there's our hello 5, 2. Okay, if I want to force Java to add that 5 and 2, I need to group it in parentheses because parentheses come first in the order of precedence. So now Java will look first at the 5 plus 2 inside the parentheses, add those integers together to get 7, then it'll be hello, a string concatenated with the 7. So we'll go ahead and run. Right, and now we have our hello 7. So now I could throw in some additional operations to play with. So let's try 5 divided by 2. Then we'll do plus hello. And then let's add on a 5 modulo 2 to the end. So before we talk through this, go ahead and see if you can anticipate what that is going to output. If you paused and you came back now, let's talk through it, and then we'll run and see if your prediction was correct. So order of precedence is going to be parentheses first, and we don't have any of those inside of the print line method. Then next we look for exponents, then multiplication, division, and modulo from left to right. So here we have a division, 5 divided by 2. This is integer division though, so the answer will not be 2.5 because these are not doubles. Right? Instead, it's going to return just the truncated form. So 5 divided by 2 is 2 in integer division. Okay, then we also have a modulus. So we did the division. Now we come to the modulus because we're working left to right. And 5 modulo 2, that's going to return the remainder when we divide. And that's going to be a 1. So then Java looks at those answers and concatenates with the word hello. So we're going to have 2 hello and 1. So let's go ahead and run that. Okay, and there it is, 2 hello 1, just like we expected. Okay, now if instead of an integer, I wanted to have this be a double, I could take my integer 5 and divide it by 2.0, and an integer divided by a double returns a double. So now we can run, and we should get 5 divided by 2.0 to be 2.5, and then our hello, and then our 1, right? And we can see that that worked. Now, if you have an integer divided by a double, but you really want that output to be an integer. Remember, we talked about casting. So I could cast this result as an integer. So now Java would do the 5 divided by 2.0. It would calculate that as a double, 2.5, then cast that double as an integer, which would truncate it and turn it back into a 2. So let's go ahead and run that and test it out. And there we are. We're back to the 2 hello 1.